Welcome to lesson 3, part 2. Now we are going to move on to the factored form of quadratics and what that means for graphing and for solving some word problems. So I just wanted to review the zero product property that we talked about earlier this year. And the whole point of the zero product property is that if A times B is 0, then either A is 0 or B is 0. And that really helps us solve equations like this, because when I have two different factors multiplied together to 0, I know that either this one is 0 or this one is 0. And it's very easy to see that the two solutions, the two x values that make that happen, are x equals -1 and x equals 3/2. Now maybe this one's a little bit trickier, so I'm going to help us figure out a way to do this guy, and it's the following. So if you set 2x minus 3 equal to 0 and then just solve for the x value, okay, that's the way you can figure out, not by inspection, by actually solving what the x value is. And of course, the reason that's helpful in this unit, which is graphing, is it helps us find, and this is a typo actually, oh no, that's right, it was a typo, I fixed it. So we're finding the x-intercepts of anything. In order to do that, you set y to 0 and solve for x, because of course the x-intercepts are wherever the y values are 0, right? So if that's y. Okay, so if I look at something like this guy here, I know very easily that my x-intercepts are -5, 0. We want to write them as coordinates. And then for this one, using a similar method as before, -1/3, 0. Okay, so that brings us to what I really want to talk about today, and that is graphing quadratics. So if I give you something like this, we actually have already seen this on the front page. We're going to factor it. Okay, and then if I want to state the x-intercepts of this, it's now quite easy. I know all I have to do is set the y value to 0, and then by inspection, I can pretty easily see that the x-intercepts are 2, 0, and -1, 0. Vertex, so we talked briefly about what a vertex is. A vertex is basically a max or a min of a parabola. Now, we haven't really talked about this yet, but I'm sort of getting ahead of myself, and then we're going to review it next time. But the shape of a quadratic is either one of these two orientations, but it has the shape of a U. And so we call this concave up, and we call this concave down, or facing up, facing down. And we can see that with a concave up function, this thing will have a minimum, and with a concave down function, this thing will have a maximum. But actually, these are both considered a vertex. Okay, so vertex, another word for vertex actually is a turning point. Very literally, your graph goes from decreasing to increasing. It turns basically around. So how would we find the vertex of this guy? Well, I don't even really need to know how to graph it, but what I do need to realize is that I can use my x-intercepts that I found up here to help me do this. So what I'm going to do is sort of roughly plot my two intercepts, and then I can, even though I have no idea what this looks like, this is very hard for me to do, even though I have no idea what this looks like, okay, I know that it has this shape. And basically what I'm trying to find is this point right here, the minimum. So as you can imagine, and as we did discuss in class, this thing is actually symmetric, meaning I can fold it in half along a vertical line onto itself. So what that means is actually this vertex should be halfway between these two x-intercepts. So in class, what we did was we used our midpoint formula just of the x values, and we called this thing xv. So this v stands for vertex. So what we're going to do is add our two x-intercepts and divide by 2, as we did with the midpoint formula in our last unit. Okay, so in this case, xv equals -1 plus 2 divided by 2. It's kind of an ugly number. It's 1/2, but that's okay. We can work with that. So as you can imagine, our vertex actually needs 2 coordinates. So I know that the x value is 1/2, and the way I find the y value of my vertex is just by subbing it in to the equation that I'm given, so right here. So it's 3xv squared minus 3xv minus 6. So from here, what I can do is just sub in the xv value. So I get yv. I'm going to zoom in a bit. So I get yv equals 3 1/2 squared minus 3 times 1/2 minus 6. Okay, so that gets us 3/4 minus 3/2 minus 6. You don't have to do all this work in your notes, but I just want to show you what this is in the lesson. So we get, oops, little mistake there. So this should be -6/4 minus 24/4. So we get -27/4. So in the end, our vertex is 1/2 -27/4. So the idea is we find the midpoint. So maybe let's summarize this. Okay, so to find the vertex, okay, our first step is to find the two x-intercepts. More on that later, because sometimes there aren't two. Find xv by taking the midpoint, and then find yv by substituting into the formula. Okay, and then we get the vertex. The vertex is xv, yv. All right, so using the 3 points now, we can graph the parabola. Okay, so we've got -1, 0, 2, 0. We know that -27/4, what's that? That's going to be -6.75. So when we go to graph this at 1/2, we can just try our best to make it look good. Okay, and then my only request here is that when you draw this thing, as I've always asked you to do, make sure you fill in the entire field of view of the graph. No arrows, please. Okay. Great. So we have graphed our first quadratic in factored form. So I'm going to give you guys some time now. I'm going to pause the video, and I want you to sketch out the following parabolas. The first few are already in factored form for you. The last 3 are not. You have to factor them first and then graph them. and then I'll catch up with you when we get to the word problems.